Hey everybody, I want to talk about a new kind of equation here. This is the quadratic equation. You're gonna love it. Um, in the last video, we were talking about linear equations. They're called linear equations because they make nice straight lines. Okay, and you can see the lines there. I got four examples of this. All of them are listed over there on the right-hand side, and you can see that um, that first one there has a formula of y equals x plus 6. That is the purple equation, matches up with the purple line. And you can see it right there that indeed it does cross at y equals 6. So if I'm thinking about the y-intercept, I could set x equal to 0, and I just get that y equals 6, find my y-intercept. If you want to find an intercept, set the other variable equal to 0. If you want the y-intercept, set x equal to 0 and solve for y. If you want the x-intercept, set y equal to 0. You could do that. Okay. If we were to do that here, if I put a 0 there for y, then um, that would give me x equals 6. I'm sorry, 0 equals x plus 6. I'd subtract 6 from both sides, and I'd end up with x equals -6, which you can see is this other point down here. Okay, but those are linear equations. Those are straight lines. We also learned that there was a slope and a y-intercept. I guess we've talked a little bit about the y-intercept, but this red one here, B, it's got a y-intercept of 3. You can see that right there where it crosses the y-axis at 3. And the slope is right there, the number in front of x. You can't see it, but there's a little invisible 1 right there. There's a slope of 1, meaning this thing goes over 1, up 1, and it keeps doing that, over 1, up 1. You could go over 2, up 2 if you wanted to. The ratio, the fraction, the slope is still the same. C, the only difference is that the y-intercept is now -2. Same slope of 1. So you can see all these lines are running parallel to each other, but now we've pushed it down. Changing that last number, changing the constant determines how high on the graph it rides. And up here it's +6, then +3, and -2. That last one is -6, and it's all the way down there. But you're just kind of adjusting everything vertically and moving that. And that's all that last number does. You say, how steep is it with that number right there, slope? And you say, how high or low is it? What's the y-intercept right there? And you got your linear equation. So that's pretty nice. Um, Quadratics are different. Quadratics don't make straight lines. They make these kind of lines. They make these bowl-shaped things. And I've got a quadratic equation up there. You can see y equals x squared plus 2x minus 8. This is what it looks like. Okay, and it's no longer a nice straight line. Now that kind of got stretched up, so the pixelation's pretty bad there. Um, but when we talk about solving quadratic equations, there's kind of four tricks that I want to show you here as quick as possible. We've already talked a good bit about factoring, so we know how that is, but we didn't use it to solve equations, did we? So we'll talk about that. Completing the square is an old process. The ancient Greeks used to do it with a stick in the sand. They draw a picture, and I could show you that if you're interested. Maybe ask about it in class, something. I don't know that we need to spend our time there. I do have a quadratic formula. I would like you to know how to do that. And of course, graphically, you're just pushing some buttons on the calculator. What does it mean to solve a quadratic equation? Well, we're really looking for the roots. We're looking for these 2 points where the curve crosses the x-axis. Okay. Um, when we had a linear equation, taking a step back again, but with a linear equation, something like, I don't know, how about y equals 3x plus 2. Okay. If I were to solve this for x, the first thing that I would do is put a 0 there for y. And effectively, you can already see why I'm looking at the x-axis. If y equals 0, that means I don't have any height or depth below this thing. I'm somewhere on this line, right? On the x-axis, and I'm trying to find x that satisfies that. So I'd subtract 2 from both sides, and I'd divide by 3, and x would be equal to negative 2/3. And there would be a point right here where that would cross. The slope is 3, so it goes up and over, and I'd have my other point there. But the solution is that point where it crosses the x-axis. This is exactly the same thing here, only now there could be two of these things, right? You can see in the picture here that I've got a point here and a point there. So we're going to want to find both of those. I could also draw a parabola, though, that didn't have any real solutions, if it comes down like this and goes back up, it doesn't touch the x-axis at all. So I could have no solutions. It could come down and touch at one little point right there, and I could have one solution, real solution, or it could totally cross that thing and have two solutions right there. So that's what we're trying to do. Remembering that algebra is amazingly useful in real life, and so often in life we're looking for the answer. Those are the answers that we're looking for. Okay. And so these four methods here I'd like to tell you about real quick. And let's do this with factoring since I've got a little bit of space here. Um, if I were to factor this thing up here, you already know how to do that. So I'll put that in. I've got something times something to give me x squared. That's clearly x and x. I need something here that multiplies to 8 and subtracts, my signs are different, to 2. Well, I'm thinking of 4 and 2 would work out nicely. If the signs are different, that means one's positive, one's negative, but I want this cross term to end up positive. So I think that's what we need. Let's check the outer. It'd be negative 2x, and the inner times the inner would be positive 4x, and I put those together, and indeed I would get that. So that is the factorization of that trinomial. And just like we did this right here, we put a 0 out in front. I want to know where that's equal to 0. Okay? Just let y equal 0. That puts us on this x-axis, and that means that we're going to find a solution for that equation where it crosses the x-axis. All right, so here I've got a 0, and there are two things that are multiplied. I got x plus 4, and I'm multiplying that by x minus 2 together. Um, they equal 0. When I multiply, I get 0. Now, there's only, the only way you can multiply and get 0 is if this one's 0 or that one's 0. Well, I guess both of them 0, but the trick here is to take this first thing and said, well, maybe this one's 0. And if that's the case, it would look like this. Take the first binomial, set it equal to 0, and solve it. Okay? So I would get x equals negative 4. And if you come back here, you see here's 0, negative 1, negative 2, negative 3, negative 4. That's that solution right there. X equals negative 4, so we just found it. Okay? Again, I'm multiplying, getting 0. The only way I can multiply and get 0 is if it's 0 times 7 or 0 times 4 or 0 times anything, 0 times 0. But I got to have a 0 in there. We just said, well, what if this one's 0, and found that solution. To get the other one, of course, we're just going to take the other binomial, set that equal to 0, and there x minus 2 is equal to 0, add 2 to both sides. My other possible solution is x equals 2. Here's x equals 0, x equals 1, x equals 2 would be that other point right there. So yeah, we just found the 2 points where the parabola, and that is the name of this funny curved bowl shape here, parabola, crosses the x-axis, and that's not too bad, right? Factoring is a perfectly good way to do it if this will factor. Now, if this had been a 9 or 7 or something else, then it might not factor as nicely. So Factoring's not going to always work, but when it does, that's what you do. Factor it, set it equal to 0, and then take each polynomial, set that equal to 0, and solve for those solutions. All right. Uh, Here's that same problem. I don't know why I did it back over there, so I don't think we need to worry about that. Well, okay, let's complete the square. Here is completing the square. Again, this is the same problem, so we're going to get the same solutions. And this is one of those things people really have forgotten how to do. Um, but let me just show you real quick. The way we do it today is to get this constant over on the other side. So I'm going to add 8 to both sides. That's going to cancel the -8 on the left and give me a +8 over there. So now I've got x squared plus 2x equals 8. All right. Now here comes the tricky part. What I got to do is look at this number right here, and I need to add something to both sides of the equation. And what I'm hoping to do is to make this side a perfect square, and then I can take the square root of both sides and get rid of that squared right there. Okay. That's really the trouble with quadratics. When you've got x squared plus 2x and some constant, something like that, you've got, I can't just, I can't factor an x out. I can't, I got to do something else. And factoring is an option. Completing the square is another one. So there's a little trick we can pull here. What I want to do is to add this, add half of that second coefficient, the second number right there, that 2. Let's put second number squared to both sides. And that's the trick to making this thing work. All right, so let's give that a try. Clearly, if the number right here is 2, I want to take half of that, which would be 1, and then I need to square it, and 1 squared would be 1. So I'm going to add 1 here, and I'm going to add 1 here. That's perfectly legitimate because I can add the same thing to both sides anytime I want. But the advantage of doing that is now this is a perfect square, and we'll factor like this, x plus 1, x plus 1, okay? When you take half of that number and square it, add that to both sides, you're guaranteed to have something over here that will factor, and it will factor as a perfect square. So I can write x plus 1 squared, okay? On the right-hand side here, I've got 8 plus 1, which would be 9. So it looks like that. And now I can take the square root of both sides to get rid of that squared. So let me mark that here so we don't forget what we're doing. We'll take the square root of this side. That's fine as long as I take the square root of the other side. And you know that the square root and squared are opposites, so those are going to cancel. And that's just going to give me an x plus 1 on the left-hand side. And over here, I've got the square root of 9, and everybody wants to say 3. I actually need to consider both of them, plus 3 or minus 3. If I take plus 3 times plus 3, I get, I'm sorry, times, if I multiply 3 times 3, I get 9. If I multiply -3 times -3, I get 9. All right. So I've got this right here, and I need to consider those independently. I could have x plus 1 equals +3, or I could have x plus 1 equals -3. And I need to solve both of those for x. So let's subtract 1, and that would give me x equals 2. Or I could subtract 1 here, as long as I do it on the other side, and x will equal -4. And if you remember, those are the two solutions that we got doing it this way, -4 and 2 right there. Okay, so that's completing the square. Again, the first step is to get the constant by itself. Well, maybe even before that, you got to have set y, get it in descending order with y on one side, set it equal to 0. Get it constant by itself. Maybe we want to call that step 2. I don't know. I'm trying to overthink this, I think. Um, but I'm going to put get y equals some number times x squared plus some number b times x plus some number. And these could be plus or minus here, right? Obviously. And I need to set that equal to 0, effectively make that y a 0 right there. All right. We didn't deal when there's an a. Technically, we got to get rid of the a too. So I'll put that in. Once I've done this, it would be down to ax squared plus or minus bx equals minus or plus c over here. I do need to get rid of that a as well. And we're kind of getting into gory details that maybe are best left alone. Get rid of any a coefficient. Okay, so I divide everything through by a. That's going to give me x squared plus or minus b over a. X equals minus or plus c over a, like that. Okay, and here's where we come in, and we're going to do this thing right here. We didn't have to deal with step 3, 4, but for step 4, add half of b over a squared. Okay, to both sides. All right, step 5 is going to be factor it, or it's always going to be a perfect square. And then we're going to set each of those equal to 0. So I'll just put set that I don't know what set it each equal to 0 and solve. Okay, so that's completing the square. I told you that the ancient Greeks used to do this, and they did it totally different. To them, everything was geometry. So, while we're going down the road here for math, what they would do is they would draw a square, and that square was x by x. So that took care of the x squared. And then right here, you've got this 2x. So they would draw a little rectangle on top of that. That was 1 by x. Notice that the area here would be x squared. This would be 1x. They draw another little rectangle right here. That is 1x. So those two together give me the 2x. And then I need to add something to both sides. It was 1 by 1. So I add this right here, which has an area of 1. That's what we added to both sides, took care of that right there. And then the whole thing is equal to 9. Um, and then they worked at, just drawing this picture in the sand. I get chills every time I see that. But you see why they call it completing the square? Like, what do I have to add right here to turn that back into a square? How do I complete that square? Anyway, uh, this is the quadratic formula. Okay, this is probably a lot more practical for today's use. And if you end up with one that won't factor and you don't want to do it in your calculator, then this is probably your go-to method right here. And the quadratic formula is this thing in the box down here. And it's pretty easy to use, and I can show you how to do that in just a little bit. But you might want to know, where does that come from? The place that comes from is what we were just talking about, completing the square. So again, all I have to do here is step 1 is get that constant term off of this side. So I want to cancel it, subtract c from both sides, and that will get me down to ax squared plus bx equals negative c. Next up, I want to get rid of that a. So I'm going to divide everything by a here. Effectively, you're dividing both sides by a, but don't forget to get both of them. So I'm going to just put it under all of those like that. And that cancels that a right there, which is what I was endeavoring to do. So now I have x squared plus bx over a equals negative c over a. Um, I need to add something to both sides of the equation. That something should be half of b over a. Okay, so I'm taking this number right here, b over a, the coefficient of x. I need to take half of it, sorry. And the easiest way to do that would be when I take half, I don't know what I'm trying to do here, draw an arrow, I think. So that's going to turn into half of b over a, or b over 2a. And then don't forget to square it. So I'd have b squared over 4a squared. Everything there has to get squared. The b squared is b squared. The 2 squared is 4. The a squared is a squared. All right. This is what I want to add to both sides. So we would just come in here and say plus b squared over 2 over 4a squared. And over here, I need to do plus b squared over 4a squared. All right. Now, if I've done everything right, then it should look like this when I'm at that next step right there, bx over a plus b squared over 4a squared equals negative c over a plus b squared over 4a squared, like that. All right. Now, again, all we're trying to do is derive this. I'm not really trying to solve for the equation. I just wanted to see where this comes from. Okay. And this is what somebody did much later after completing the square for generations, I don't know, 1500 years or something. They said, hey, look at this. And they went, oh, that's pretty neat. Okay. Right over here, we're adding two fractions. So clearly I got to get a common denominator there. And I've got an a on the bottom of one fraction. I've got a 4a squared on the other one. I need to make that the same denominator. So 4a squared would be that least common denominator. I need to multiply here by a 4a so that 4a times a would give me 4a squared. And I can do that right here. And you can already start to see some of these bits popping up. There's a 4a squared and there's a on the bottom and stuff. So we're headed in the right direction here. But this, now that we've done that, I'm not changing anything on the left here at the moment. Bx over a plus b squared over 4a squared equals. Now I've got a common denominator, so I'm going to keep that common denominator of 4a squared. And I got a negative 4ac and a positive b squared. Let's get that positive b squared out front. It's going to look like that. Okay. And you can already see there's a b squared minus 4ac over, that's the square root of that. All right. So now let's factor the left-hand side. This is guaranteed to be a perfect square. So what I need to do is take the square root of this thing and put that front and back. And right here, the signs are alike and they're both positive. So I've got this, and there's that perfect square that we were looking for. X plus b over 2a multiplied by itself or squared equals all of this stuff. B squared minus 4ac all over 4a squared. Okay. Now, I don't need you to do that. We're not even done with it here. But again, this is just trying to get to the point where you go, oh, that does work. Okay. We'll make some room up here. We're going to finish this up real quick. And then we'll have the quadratic formula that we can use and make life a little bit easier here. I think you remember that the next thing to do was to take the square root of both sides like that, okay? And I'm going to let the square root and the squared cancel each other. So on the left, I've just got x plus 2b, x plus, here we go, x plus b over 2a. And over here, I've got the square root of b squared minus 4ac over 4a squared. Wonder what I could do with that. Well, if I go ahead on the left and take the square root of all this stuff, at least the bottom, all right? Here's an x plus b over 2a, nothing changed. This would be the square root of b squared minus 4ac over the square root of 4a squared. Square root of 4a squared is just 2a. Like that. And so I'm trying to solve this thing for x. All I have to do is subtract that b over 2a. And I no longer have an equal sign there. Let me try that again. We just added that to both sides. Come on, there is it. There it is. Okay, so let me get rid of that. And we're almost done here, I swear. Okay, and then we had this, all this was positive here. Okay, and I got a common denominator, so I can put that together. It's just going to be a 2a on the bottom, negative b. When we took that square root, it's actually a plus or a minus. So, and remember, we're looking for two solutions. So the plus will give us one, the minus will give us the other one. There it is. All right. Sorry for dragging you through that, but I think it's important to kind of see where these things come from. What do I do with it? Okay, I got it now. It's supposed to give me X, right? I'm supposed to be able to get the answer X here. I don't know. Well, A, B, and C were these three numbers right there. A, B, and C. So I got to grab those and shove them into the formula, and that's another way to get X right there. I think I got one for you to try. Same old problem. All right. So remember how our form had A was the coefficient of the x squared term. That's a 1. B is the coefficient of the, maybe, I don't know if I said that right, the x squared terms A. The coefficient of the x term is b, and here it's a 2. And c is the coefficient or constant back here. It's a negative 8. If there had been a subtraction there, you'd want to put a negative 2. If there was keep up with the signs too, all right? But in this problem, a is equal to 1, b is equal to 2, c is equal to 8. And they're telling us if we take those three numbers and just plug them in everywhere we see a, b, and c over here, then we'll get x. We already know what the answers for x are supposed to be, so we ought to be able to see real quick if this is working for us. But I'm going to write down the formula here. Anytime I use a formula, I really kind of like to write it down and just make sure that I get that right. It's a good starting place. And then I can take A, B, and C and plug it in down here. B is 2. Formula says you need a negative in front of that, so that's a negative 2 plus or minus the square root of B. B was 2. Don't forget to square it. Minus 4 times A. A was 1. And C is a negative 8. Okay. And then downstairs, I've got 2 times A, where A is equal to 1. All right. So we've put the numbers in now. We got the coefficients A, B, C. You got to have this in descending order with x squared term first place, x is in the second place, and the constants at the end of the whole mess. Okay. But now I can kind of come through here and turn the crank, and you can do this by hand. I'll do it first by hand. We'll do the other one on the calculator, see which one you like better. But here's a 2 squared, which would be a 4. Here's a negative 4 times 1 would still be negative 4 times negative 8 would be positive 32. 2 times 1 is 2. Let's see what that is going to give us here. 8 times 4, 1632. I wrote the wrong number here. That's not 36. I was going, something's wrong. I went ahead and added that 4. Okay, there we go. All right. And of course, up underneath that radical, 4 and 32 would be 36. And here, the square root of 36 is plus or minus 6. And down here, I have a 2. And if I take the negative 2 and add 6, then I would have 4 over 2. And 4 over 2 is 2. So one of the solutions is x equals 2. Okay. To do the other one, I want to use the negative sign right here. So that would be negative 2 minus 6 over 2. Negative 2 minus 6 is negative 8. Negative 8 over 2 is negative 4. So the other solution is x equals negative 4. And if you remember, those are exactly the same two numbers that we got before. That's the quadratic equation. Well, that's solving a quadratic equation by using the quadratic formula. This thing is the quadratic formula. And you plug numbers into a formula, you get the numbers from our quadratic equation over here, where it's equal to 0, and you've got it all in descending order and everything. Okay. Let me show you how to do that on the calculator real quick here, because you may want to do this someday. I'm going to come in right here, actually right here, where I've got those numbers in, and I'm going to just put this in. You got to be careful with the parentheses here, though. So let me draw some of those in so you can see them. That whole top has to happen before you divide by 2a. Let me come down here, actually. So I'm going to tie all of that up in a set of parentheses. Secondly, as soon as I hit the square root, the calculator, if you have this kind of calculator, is going to automatically start a second set of parentheses. So I have to remember to close that up before I do that. Okay. And then lastly, make sure that this gets multiplied together and you don't put a multiplication there, which would move up top. Here it's a 1. It wouldn't matter, but you could see how with other numbers it very well could. So here's that opening parenthesis. I got a negative 2. We're going to use the plus one time and the minus the other. So let's hit plus, and I've got a square root 2 squared minus 4 times a1 times c negative 8. And right there, you can see that little parenthesis that it started, that red dotted one is right there. So I got to close that, and I got to close the numerator, these two parentheses right there. And then I need to, the easy thing to go is 2 times 1 is 2, and just go divide by 2. Okay. There's this solution right here. You can see we got exactly the same thing. Okay, so there's that one. There's a little trick you can do. If you go second enter, that pulls up the last thing you typed in. And this is a nice trick because I want to do exactly the same thing except have a minus sign right there. So if I use the arrow key and just step up there, change that to a subtraction, then there's my other one, x equals negative 4. So we got our other solution there. Now, it takes a little bit of practice getting that in the calculator, and you better watch those parentheses and make sure everything gets in the right place. All right. But the quadratic formula is a pretty good way to do this thing, especially if it won't factor. And so that's maybe the best reason to have the quadratic formula at your fingertips. I'll just put here, if won't factor, then this is a really good way to go at it. In my physics class, we have problems where there's a cliff and a cannonball gets shot off. A kid throws a rock, a water balloon, something. There's some kind of object right here. And if he throws that thing up in the air and it comes down like that, that's the path of the rock. Can you see the parabola right there? If you finish up the other side, kind of go backwards in time here, and that thing's going to hit either here or here. If you want to know the time that it takes to hit the ground, that's a quadratic. And they don't factor very nicely because there's decimals and weird numbers in it. Okay. So this is kind of your best way to go at it. And so my physics students don't really like it either, but that's kind of the best game in town. It wouldn't be much fun to complete the square on it either. You could do it, but again, there's decimals in it, and you got to take half and then square it and add that to both sides. And um, this isn't a bad way. And like you saw in the calculator, once you get the hang of it, you can type that thing in pretty quick and get that. Okay. That brings us to the last one here. How do I do it on the calculator? How do I do it by graphing? We've already said that that parabola comes down and it's going to cross the axis in two places, and we want to know where those are. Okay, so let me get out the calculator here again, and we'll do this. What you want to do is to hit y equals and put your equation in right there. So I'm going to try to keep up with this as we go. Step one, put the quadratic, and by the quadratic, I mean this part right here. Make sure that you've got it equal to 0. Everything's over here by itself. It doesn't have to be in descending order. It'll straighten that out. But put the quadratic in the calculator. So I'm going to do that right now. I'm going to hit clear and get rid of that mess. And I'm going to hit my X button, hit the squared, go plus 2x. All right, there's that X button again. And then subtract 8. There's my quadratic, just like I've got it underlined there. All right. Now I can hit the graph button right here. And lo and behold, that's the picture that I have over here blown up too big and it's all pixely looking. But the second step would be to hit your graph button. Now, sometimes it won't show it. If I had, I'm going to draw on top of this. I don't think it'll work for the calculator. Might even, no, it's good. Sometimes that quadratic might look like this. Oh, yeah, I can't draw on top of that, can I? Okay. But it might be totally off of the screen. So then you got to go looking for the parabola. You know, if the parabola is too big or the scale's wrong on your calculator and you can't see it, you got to go find that thing. All right. But here it showed up real nice, so we won't worry too much about that. I will say this zoom is useful right there, and you can zoom out. You can set where you want it to be. You could also hit the window button, and it says, I want to go from negative 100 to positive 100 on the x-axis. Okay. And what it's going to do is it's going to kind of squash that thing down, and you can see it right there, right? That's it's still there. It's all on there, but it kind of made zoomed way out. Okay. So when I zoom here, there's a zoom standard number 6, and that'll get me back to the x is negative 10 to positive 10, y equals negative 10 to positive 10. So sometimes you got to go looking for it. All right. Anyway, step 3, and here's where things get interesting. You've got this calc up here in yellow, and that's a second function. So you got to hit the second, hit the trace button, and it'll calc all these things. I'm going to put over here, hit the second, the trace button, but up here in yellow, you've got calc. I should have put the y equals button here. That's what you got to hit to even put the quadratic in. All right. Okay. The one that we want to calculate is the 0, number 2. We're trying to find the zeros of this function, of this quadratic equation. Why do they call them zeros? Because the y is equal to 0. Remember, we've slammed this thing down onto the x-axis because we set that y equal to 0 right there. So I'm going to go down and hit enter. And it's going to ask me 3 questions, namely, get me on the left of this where you think it crosses. I think it crosses right there. So I need to be somewhere on the left of it. I'm on the left of that. If I move to the left, that's where I am. But I can use the little arrow key, and now I'm on the right of it, right? I went too far. It wants to know where to look. So it says, give me a left bound. I'm going to look between the left bound, and all you got to do is get somewhere on the left, anywhere on the left, hit enter. And then it's going to say, what's the right bound? Where do you want me to look? And I want it to look between those 2 points. You can see it added a little arrow right there. So there's a little region that it's going to search for a zero. And then it says guess. So I can take a step back and say, that's about as close as I can get to it. Go find it for me. All right. And it's like Spot, the rover, goes out there, woof, and finds you throw a tennis ball and he goes and finds it or something. I'm going to put left, right, and guess. And on each one of those, you got to come in there and hit enter and get those three. But when you do that, you can see that it says, I've got a zero. I found one at x equals 2. All right. If you want the other one, the one that's over here, well, that's outside the region we told it to look in. So you'd have to do the whole thing again to get the other one. Second calc, find me a zero. I need to get the left bound back over here, right all the way down the roller coaster. Now I'm on the left-hand side. Here's the bump, and I'm over here left of that somewhere. Don't worry about the up and down. Get somewhere on the right. Take a couple steps back and get as close as you can. It's going to do it just as quick as you can. But there's the other one. The second zero, the other solution to this problem is x equals -4. All right. And it'll just put it right there on the thing. So that's I guess that's the modern way to do it, right? But it's nice having options. And to me, this is a little more tedious. The calculator is a little more tedious than doing the quadratic formula. You may feel completely different about that. I'd like you to know how to do it by factoring, how to do it by the quadratic formula, and how to do it by graphing. Um, I could probably forgive you if you didn't know how to do it by completing the square. But those are the four options that we really have there. Options are nice. So um, there you go. Okay. Now this says higher order polynomials. That's not really a higher order polynomial. Oh, I see what's going on here. We got two like terms. Okay, I'd put those together. 3x squared minus 5x minus 2x. That's minus 7x equals 0. What can I do there? That doesn't look like it'll factor. Oh, wait, I can factor. Look at that. There's an x here and an x there, right? There's a common factor of x. Let's yank that x out front, and then I'll have -3x minus 7. That's all equal to 0. Oh, gee, I'm multiplying two things. I'm multiplying x, and I'm multiplying -3x minus 7, and I get 0. That means either x equals 0, and that's, bam, there's a solution right there. Or uh, -3x minus 7 equals 0. Again, if you're multiplying and the answer is 0, something's 0, right? So set this part equal to 0, set this part equal to 0, and see what you get. Here I'd have to add 7 to both sides. That would cancel that. I'd end up with -3x equals 7, and I could divide by -3, so x equals -7/3 would be the other solution. This is a different problem, right? So I'm going to get different solutions. But watch for that. Maybe there's a common factor, and I can pull that out. Let's see what the next one here is. Oh, yeah. Here, this is called the discriminant. And the discriminant is this little piece right there. You can see that it's the thing that's underneath the square root in the quadratic formula. So we've seen this guy before. We even saw where it came from, and we kind of know what that is. But if you take that same A, B, and C that we plugged in over here, then there's kind of four possibilities. If B squared minus 4AC is exactly equal to 0, then that parabola comes down and just kisses the x-axis right there, and you're going to have one rational solution. Okay? There'd be one solution that is a rational number. It could be a whole number, could be an integer, could be a fraction, could be a decimal, but it's rational. All right? If b squared minus 4ac is greater than 0, and it's a perfect square. If you do b squared minus 4ac and you get 9 or 16 or 25 or 100 or something like that, then that tells you that there's two rational solutions. That's kind of like the one we were looking at. Ours was over here like that. We had 2 and -4, but it crossed the x-axis in 2 points. So we got two solutions and they were both rational numbers, -4 and 2 or whatever. This one might be, I don't know, making up numbers here now, but 6 and 10 or something like that, right? 10.394. That's still a rational number. It could be 10 and 7/16 or something else. It could be a fraction, it could be a decimal, but it's a rational number, and I got two solutions because the parabola is down low enough to go under it. All right. If it's greater than 0 and it's not a perfect square, then I've got two irrational solutions. And this thing might cross here. It's on the x-axis, but it's not a rational number that I can write as a fraction or a decimal or a whole number or an integer. It might be the square root of 5 and the square root of 7, something like that. Okay. Still have two solutions, but now they're irrational numbers. And the discriminant, this number that gets cooked up out of this, would tell me that. Okay. There's one other possibility. If the parabola is like this and it doesn't come down and touch it at all, I think we've already said that. There are 0 real number solutions. Okay. But there are still two solutions. They're just called complex numbers. Okay. And that's a different kind of number that we haven't really talked about, but need to at some point. Maybe not today. All right. So just kind of store that away. It doesn't cross here. So I don't get a regular number that I can use in 99% of real life. Okay. But there are a lot of things that we can do with complex numbers, and they're really important in other places. Okay, so let's wave off on that one for right now. The discriminant, if I go back and I get these numbers that we had here, where was it? We had a equals 1, b equals 2, c equals -8, and I just run those just to see what this would look like. A was equal to 1, b was equal to 2, and C was equal to -8. I'm going to make sure I got those right because, yeah, okay, A, B, and C. So if I just come in here and put that in, B squared, that would be 2 squared, which would be 4. I'm working upside down here now. 4 times A times C, and that's going to be -4 times 1 is still -4 times -8 would be +32. And 4 plus 32 is 36. Okay. So my discriminant in that problem that we worked 3 or 4 different ways was not equal to 0. It was greater than 0, and it's a perfect square. 36 is definitely greater than 0, and it is a perfect square. So I got two rational solutions like -4 and 2. All right. But these other possibilities are out there, and just good to kind of know about them. You want to see one with complex numbers? Here's what happens. Um, if I do this one, if I set it equal to 0, I'm going to use the quadratic formula here to do this. It's right there. So that's kind of a hint. I take the coefficient of x squared. There's a little invisible 1 sitting there. So I grab that 1 and put it here. Here's b equals the coefficient of x term. So that's a 2. C is the number right there. That's a 7. And I want to put that into this formula. I'm going to copy it over because you know me, every time I copy it, it wedges itself a little bit deeper in my head, but then I can also see what I'm doing here. I need a negative b. B is positive 2, so negative b would be negative 2 plus or minus the square root. B is 2, so when I square that, it'd be 2 squared minus 4 times a times c, like that. And down here, I've got a 2 times a, but that's a 1. And here's a negative 2 plus or minus. I could just grab my calculator at this point, but let's see what happens and why it's going to happen. 2 squared is a 4. Here is a negative 4 times 1 would be negative 4 times 7 is a negative 28. All over 2 times 1 is 2. That's going to be negative 2 plus or minus. Up underneath there, I have the square root of negative 24. You see the problem already? Over 2. Anybody know what the square root of negative 24 is? Check this out. You come in here on your calculator and you say, show me square root negative 24, and it's going to get ticked at you. All right. It says it's a non-real answer. So that's the problem here. And that complex number, you can't take the square root of a negative number and get a real answer. Okay. No real number. Okay. But it came along and people said, you know what? I need it anyway. Figure out a way to tell me what I can multiply by itself and get negative 24. You can see the problem here, right? If I take a positive number times a positive number and multiply those, I'm going to get a positive number. I need a negative number. I need negative 24 here. If I take a negative times a negative, I've got to multiply the same thing by itself, and I'm going to get a positive number. There's no way to multiply two real positive numbers and get a negative answer under there. So what they did was they said, all right, fine. Let's just define the square root of negative 1 to be equal to a number. Now, I always used I. Engineers like to use J. I can't tell you why, but that I is not a real number. It's not on the number line that we use, um, and this will work, okay? So when you get done over here, what I could do is I could say negative 2 plus the square root of 24. That's taking the positive part of this, but there's still the negative. I'm going to have to put an I on there to do this. And I need to divide all that by 2. You know what? It'd be better to not do it this way. Um, let's separate it into 2 fractions here. I got a negative 2 over 2, and I got plus or minus the square root of negative 24 over 2. This much right here is going to give me a negative 1 plus or minus. I didn't pick very good numbers here, but man, if that were 25, that'd be really nice. Huh. Anyway, we're going to get something like, let's go get a decimal version of it right now, not worry about it. 4.8989. See how it repeats and never terminates, never repeats, never terminates. What I'm trying to say, 4.89 dot dot dot, and that's where I slap that I on right there. That is a complex number. This part is real. This part is what we call imaginary. And when you put a real number and an imaginary number together, hate the word imaginary because it's not imaginary. It's just not in our universe. It's on a different plane, okay? It's on a different axis. Anyway, you're going to get a complex number right there. It is possible to graph that. I could have the real axis here, and I could have the imaginary axis here, and I could go back 1 and then up or down 4.89. I'd get a point right there and a point right there. You can kind of draw that picture. I don't know if it means anything to you, but there are places in mathematics and especially in physics where that's really important. And you wouldn't be able to get to the moon without that. You wouldn't be able to do electronics without that. You wouldn't be able to, all kind of things. So that's probably more than we need to know about it today. But we'll say more about complex numbers. Hopefully another day. I keep finding things that up. Here it is right here. All right. Okay. So we can add and subtract these complex numbers. Remember, this was a real part. There's a real part. Put them together. 7. 4 plus 3 is 7. Right here is an imaginary part. Right there is an imaginary part. Put them together. I got plus 2 of them, plus 6 of them. That's plus 8 of them. All right, now I haven't touched this part back here, so I got to copy that and make sure I get all that as well. Notice that I'm subtracting all that, so wouldn't hurt to write out that I'm really saying minus 2 and minus I, almost like we're distributing that negative sign in there. Okay, but the 7 and minus 2 would give me a 5, and the 8I and the negative I would be, when I take one away, would be 7I. There is a complex number, and you can add or subtract it. We added these two, we subtracted that one. You got it. All right. Here is multiplication. Remember, I was the square root of negative 1. So if I multiply that by itself, the square root of negative 1 times the square root of negative 1 would be the square root of negative 1 squared. And the square root cancel each other, and I just get negative 1. Okay, so we could do that. Right here, I could FOIL this thing, just like I always do. First times the first would be 2 times 4 is 8, and the outer times the outer would be 2 times negative 2i, which would be negative 4i. 2 times 2 is 4. Got the I hanging on there. Next up, I do the inner times the inner, so that's 12i. And the last times the last would be positive times a negative. So that's a negative. 3 times 2 is a 6. And then I've got I squared. And remember, I squared is equal to negative 1. So uh, straightening out that, that's supposed to be a 12. I, uh, this is a negative 6 times a negative 1 from the I squared. Negative 6 times negative 1 is going to be a positive 6. All right, I really should have looked at these slides a little better. 8 and 6 make 14, and I got a negative 4i and a positive 12i, and that's going to be plus 8i. There's my answer. That was kind of fun. I'll let you ponder all these just kind of as a way to think about it. I is equal to the square root of negative 1. We've already done this one, so that one's going to give me a negative 1. If I take this negative 1 for I squared and say, well, shoot, that's that right there. Now I've got a negative 1 times that third I, so I just end up with a negative I. If I multiply I by itself 4 times, I to the fourth power, these two, like we've seen up here, are going to give me a negative 1. This is going to give me a negative 1, and I'm multiplying those. So negative 1 times negative 1 is a positive 1. All right. And you could even come down here and kind of cheat. You could say these 4 made positive 1. So here's 4 of them. That's going to give me a positive 1. And then I've got 3 of them. And that's going to give me a negative I. So I'm going to multiply plus 1 times negative I. That's going to be negative I. All right. It's weird stuff. I get it. But that's kind of the 50-cent version of that. That's a little deeper than I meant to go tonight, but that's my fault because I didn't look at the slides real good. You do need it. It is part of quadratic, so it fits in there very nicely. This is probably the best place to talk about it. But I didn't mean to go on that long. So thanks for sticking around, and let's ask some questions in Zoom, and we'll get all this straightened out if it doesn't make sense now. Thanks.